All right, we're just working on some derivatives here. It says differentiate each function with respect to x. We've got a constant function, which of course we know is just something like this up here at y equals 5, and the slope is always 0. Remember, derivative is slope of the tangent line, so derivative of any constant is 0. Second one, they've got f of x. We're going to go f prime of x notation, and we'll bring the 18 down using our power rule and multiply by the 5 that was out there and reduce the power. 18, reduce it by 1 to 17. And 18 times 5 is 90. Third one here, we can use dy dx. I'm going to use y prime this time. The 5 comes down, joins the 4. That makes it a 20x to the 4th. And then the 1 in front of this x is all that's left behind for that second term. Now, just a quick little understanding thing here. If you had a function y equals simply 1x, you could put a plus 0 there. Normally you don't write the 1 or the 0, but you can understand that the slope of this line is always 1. It's a constant rate of change of 1, and that's why we have a plus 1 right here. All right, moving on to number 4, f prime of x. 4 comes down to multiply by the other 4, reduce the power. Minus 5, the constant goes away. Next one, dy dx we'll say. You could have also said y prime. Next we've got a 5/4 times the 3 that was already out front, times x to the 5/4 minus 4/4. You can say minus 1, but 4/4 is definitely more convenient. So we've got a 15/4 out front and an x to the 1/4. That's a great final answer. If you're doing a multiple choice test or something and you don't see that, maybe look for this guy instead, because the 4th root of x is x to the 1/4. Okay, good. Next, number 6. So we'll go dy dx equals, power comes down, multiplies by the original coefficient. Reduce the power. I'm just going to write it here. That becomes a negative 1/3. So we end up with 10/12 x to the negative 1/3. We should probably reduce that. That would be 5/6 x to the negative 1/3. And we can keep the negative power there. No problem with that. If you'd like, you can rewrite it as a cube root of x. Let me sneak a little 3 in there. That would be fine as well. All right, next up, number 7. I'm going to say y prime here just to change up the look. The negative 5 comes down, multiplies by negative 4, and you get a 20. Reduce the power. Now remember, when you reduce, you're taking 1 off, you're subtracting 1, so that should be x to the negative 6. Great final answer. If you'd like, you can move the negative power down to the bottom, make it a positive power. Either one is fine by me. Full credit either way. I took the liberty and went ahead and did a rewrite on this one before we started the video. And what we'd like to do is rewrite it like so with the negative power, so it's all on one level, so we're not doing a quotient rule when it's not really necessary. Next we got negative 3 times the 3, that'll be negative 9, x to the, subtract 1, negative 4. I'm not going to rewrite every time we have a negative power, but I'll do it this time. But don't feel like you have to write both of them. Just write one or the other, totally fine. Next one, number 9, dy dx equals 2/3 comes down, x to the, subtract 3/3, that'll be negative 1/3. Feel free to rewrite that if you'd like. Next one, f prime of x. We've got a negative 2 x to the 1/4, so that 1/4 will come down. It'll multiply by the negative 2. Then we're going to subtract 4/4. We will get a negative 3/4. So this 2 over 4, that'll be a negative 1/2. Then we have x to the negative 3/4. Make sure when you're writing these fractional powers that the power is still smaller font a little bit and raised, but to make sure it doesn't look like this. This is kind of sloppy right here, so don't do that, because that negative 3/4 needs to look like an exponent still. All right, so that's it for 10. Moving on to 11. dy dx. We're going to have a 4 times 2/3. I'm going to jump right to it. That's an 8/3, x to the 3rd. This is just a linear piece, so just take off the slope and get rid of the x. Negative 3 times negative 1 is positive 3, but then you're going to reduce the power to a negative 4. Remember, you're subtracting 1. Subtracting 1, so you're going to get to negative 4. Next, Number 12. 4 comes down, multiplies by the negative 1/2. Well, half of 4 is 2, but it's a negative 2. Reduce the power. Next, the 5/3 comes down, multiplies by the 3. In fact, if you can just go like that. And we'll subtract this. That'll make that a 2/3, right? So 5 is left behind. And it's going to be x to the 2/3. Last term is simply a linear term, so just pull the slope and use that. All right, just double checking here. 5/3. Good. All right, getting down to the end here. So differentiate each function with respect to the given variable. So now we have y is a function of r. And here f is a function of s. So we can say y prime of r, or you can say dy dr. They're both the same thing. And then everything else goes as usual. 15, but it's negative. 5 times negative 3, r to the 4. Minus 10, r to the 1. And there is your answer. Next one, 14. Let's do f prime of s. Or you could say df ds. Either way. And I like my rewrite style. I don't want to do quotient rule when I don't have to, right? I see a quotient, but it's a constant on the top. Let's rewrite it so we're not doing quotient rule. Negative 2 times negative 3 is a 6, s to the negative 3. Negative 4 times negative 4 is 16, s to the negative 5. That's a great answer. If you'd like, you can rewrite it like I said before. Feel free to do that anytime you want to. You should practice it every once in a while at least, just so you don't lose those old skills. And I think we're down to the end here. We got just four more left. Here we go. Number 15. F prime of x. 3/2 times 2/3 is 6/6. Look at that. That's nice. Those will go away. So it'll be x to the subtract 2/2. You're going to get a 1/2. Okay, that's good. So then now we've got, let me write this next one out. We've got a 3/4 times this 3/5 coming down, and we're going to reduce the power. So we'll subtract 5/5. We will get a negative 2/5. Cleaning this up a little bit, we'll have x to the 1/2 minus 9/20. That doesn't look like a 9. Let's try that one again. We have a 9. There it is. 20ths. X to the negative 2/5. And that's a great final answer. Sometimes they'll rewrite that as actual radicals. Sometimes we'll move that negative power down and go x to the 2/5. That's great too. But if they're going to go radicals, maybe they go all in and go all radicals. So that would look something like this: 5th root of x squared. All right, so again, practice those old skills of rewriting. Fractional powers, negative powers, you name it. All right, next up, let's switch it up. How about some red? H prime of s. We've got a coefficient out front of rad 2. Don't change it. Times 1/3 that comes down, s to the negative 2/3. I got that by subtracting 3/3. Next, I have a rad 2 times a 1/5, s to the subtract 5/5. That'll be negative 4/5. This one's kind of gross. But let's go rad 2 over 3, s to the negative 2/3, plus rad 2 over 5, s to the negative 4/5. That's a great final answer right there. Again, you could do other stuff. We could go rad 2 on top, 3s to the 2/3 on the bottom, and then you would go rad 2 over 5s to the 4/5. I'm not going to write the bottoms in radicals, but you can imagine, or you can try it yourself. All right, this next two, I think this is it, right? So yeah, last two, differentiate each function with respect to x. Problems may contain constants a, b, and c. All right, so 5 times c is a constant itself. So dy dx is basically saying the derivative of a constant. So of course that would be 0. Second one, dy dx. Let's see here. I've got a variable and I've got a coefficient out front. Now normally you take the power and it comes down and joins that coefficient out front. So let's do that. So the 3a comes down, multiplies by the 4a. We'll clean that up later. And then you reduce the power by subtracting 1. That's different. We haven't done that very often. Next, same thing here. We got a coefficient out front. So write it down. bring that 3c down to multiply by it, and then reduce the power of x. So that'll be 3c minus 1. Cleaning up, we get 12a squared, x to the 3a minus 1, minus 3bc, x to the 3c minus 1. And there you have it, number 18, finished. All right, hopefully that helped. Take your time, go back through it if you need to. Good luck, we'll see you next time.